Hi everyone. In recent competitive exams, the examiner asking one or two questions on fraction topic in the form of ascending and descending order and decimal values of the fraction. One side he is giving fractions and other side he is giving decimal values of that fraction. So we need to match them. Next, and greater one, smaller one. So to find that, if you use general methods, general denominators LCM method, so that will take much time. So he need to consume our time. So that's why he is giving that kind of problems. So we need to reduce our time. Here, some logics are there. We know the first model of this fraction. These all are like fractions, denominators are same, that's why these all are like fractions. When the denominators are same or when the like fractions given, the greatest numerator fraction is the greater one. So 17 by 13 is the greatest fraction. Next, 11 by 13 is the second greatest one, and third one 9 by 13, and last one 7 by 13 is the smallest one. So this is the descending order. If you want ascending order, small to big, so just write 7 by 13, 9 by 13, less than 11 by 13, less than 17 by 13. So first one descending order and next one ascending order. So this is the first model problem. Second model problem. In the second model problem, here he gave equal numerators. So for in the first model, equal denominator. In the second model, equal numerator. When the equal numerators are given, then the smallest denominator fraction is the greatest one. So here the smallest numerator, smallest denominator is 3. That's why this fraction is the greatest fraction. So here the greatest fraction is 24 by 3. Next smallest denominator is 7. So next one 24 by 7, and next one 14. Next small for greatest one 24 by 14, and next one 24 by 15, and the smallest fraction is 24 by 35. So here logic is, when the numerators are equal, then the smallest denominator fraction is greatest one. So forget about the numerators. Smallest denominator fraction is greatest one when numerators are equal. When the denominators are equal, greatest numerator fraction is greatest one. Simple trick: when the denominators are equal, greatest numerator fraction is greatest one. When the numerators are equal, smallest denominator, observe the difference, here the greatest numerator, here smallest denominator. So opposite, smallest denominator fraction is greatest one. So 24 by 3, 24 by 7, 24 by 14. This is the descending order, big to small. Next, ascending order, just write them in reverse order. 24 by 35, 24 by 35 is the less than 24 by 15, less than 24 by 14, less than 24 by 7, less than 24 by 3. This is the second model. If you observe third problem, here denominators and numerators are not equal. Here denominators and numerators are not equal. If you observe these fractions here, you can find difference between numerator and denominator always same. Here difference 2, here difference 2, here difference 2, here difference 2. When the difference of numerator and denominator is same, in this case, first we need to observe whether the given fraction is proper fraction or improper fraction. So if all the fractions are improper or proper, then that is easy to find the answer. Whether some of them proper, some of them improper, then we need to check which are proper, which are improper. First one, numerator is bigger one, denominator is smaller one. So is it proper or improper? Improper fraction. So remaining all are them proper fraction. Here improper fraction, here numerator is greater than denominator, that's why this is the greatest one. And in the remaining all of them improper fraction, all the denominator and numerator difference is same. So in this case the greatest fraction, so 35 by 37, 35 by 37 is the greatest one, second greatest one, 35 by 37. And next 23 by 25, 23 by 25. Here difference between numerator and denominator is same, that's why we can write 35 by 37 is the greatest one. Next these all are some easy tricks to find the answer in short time. Next 17 by 19. Next last one, smaller one, 5 by 7. So why we took here 15 by 3? Why? Because remaining in all the fractions, observe numerator is smaller than denominator. Here also numerator is smaller than denominator. Here also and here also. But in the first case, numerator is the bigger one. That's why this is improper fraction. So if all the fractions are improper, there is no problem. Just observe the difference and write them in order. But one of them is given improper. That's why first we need to write improper fractions. In other case, for example, he gave like this: 15 by 13, 17 by 15 and 21 by 19. Here 9 by 7. All of them improper fraction. See, in the first case numerator bigger, second case numerator, third case numerator, fourth case also numerator big. All of them having difference 2, 2, 2. In this case this is also easy. Why? Because all of them improper. See, when problems will come, some of them proper and some of them improper. In that case only we need to write them in careful manner. Here what is the greatest one? Greatest fraction, 21 by 19. Next 17 by 15. Next 15 by 13. Next 9 by 7. Yeah, fourth model is very important one, and it is very important shortcut to find the answer. See, most of the students they go through the denominators LCM method. The denominator LCM method is proper for academic exams. For all the competitive exams, if you follow rules and methods, it may take much time. So we need to search for the shortcuts. But sometimes shortcuts not possible. We need to learn shortcuts at the same time process. See, if you find the denominator LCM 11, 7, 19, 25, all of them co-prime numbers, so you will get bigger LCM of the denominator. So in this case, shortcut is first find the difference between numerator and denominator. What is the difference here? 4. Here 2. Here 8. Here 12. Find out the LCM of those differences. LCM of those differences. So 2 2s are 4, 2 1s are 2 4s are 2 6 are. Next again 2 1s are 2 2s are and 2 3s are. So there is no common factors for them. 2 2s are 4, 4 2s are 8, 8 3s are 24. So here numerator and denominator's differences LCM is 24. Just here difference 4, here difference 2, here difference 8, and here difference 12. Then simply to get 24, how much we need to multiply to 4? 6. That 6 multiply to this 7. 7 6 are 42. Here to get 24, how much we need to multiply to this 2? 12. 12 to the 24. So just multiply that 12 to this 5. 12 5 is a 60. Next 8 3 is a 24. That's why that 3 multiplied to this 11. 11 3 is a 33. Next 12 2 is a 24. So that's why that 2 multiplied to this 13. 13 to the 26. So which one is greater? 60 is greater. That 60 belongs to 5 by 7. So the greatest fraction is 5 by 7. Greatest fraction, first one 5 by 7 is the greater one. Next second one 42. 42 belongs to 7 by 11. And next 33 or 26? 33. So that 33 is nothing but 11 by 19. The smallest fraction is 13 by 25. So this is the easy method. If you find in general method, you need to find the LCM of 11, 7, 19, 25. So you need to multiply all of them. So that will take much time. Just to find out the differences, then find the LCM of differences and multiply that particular value with the numerators. So here you will get 42, 60, 33, 26. Greater one 60. That's why 60 is the greatest fraction. So this method is useful for some kind of problems when the denominators and numerators are different and the differences also, differences between LCM and differences between numerator and denominators also different. In that case we need to use this method.